News from the semiconductor industry often feels like distant headlines until it impacts the hardware you rely on every day. Recently, reports confirmed that the co-founder of Supermicrocomputer, Yi Xianliao, was arrested alongside associates for allegedly orchestrating a scheme to smuggle approximately $2.5 billion worth of restricted Nvidia graphics processing units to China. This is not just a story about corporate law or international trade disputes. It is a stark warning for anyone responsible for building machine learning systems in a sanctions-heavy environment. Here is the thing you need to understand immediately. When you are scaling machine learning operations, your infrastructure is only as secure as your supply chain. If you are designing a system that depends on specific high-performance chips from a single vendor, you have built a single point of failure that can be exploited by geopolitical forces. The arrest of these individuals highlights a massive scale of evasion targeting United States export controls on advanced semiconductor technology. But for you, the data scientist or the machine learning engineer, the risk is not in the smuggling itself. The risk is in your lack of resilience when those chips become unavailable. Consider the architecture of a modern deep learning pipeline. It is often built on the assumption that hardware availability is constant. You buy a cluster of servers, install the drivers, and start training models. You assume that when you need more compute, you can order more GPUs. The current regulatory landscape has shattered that assumption. The Export Control Reform Act now restricts the transfer of dual-use AI hardware to specific countries. This means that if your supply chain is opaque, or if your vendors are operating in gray areas, your procurement can be halted overnight. So, how do you mitigate this risk through architecture? The first strategy is diversification of procurement channels. Relying on a single distributor or a single manufacturing partner is no longer a viable long-term strategy. You need to map out alternative sources that comply with current regulations. This means understanding where the chips are manufactured, where they are assembled, and where they are shipped from. It requires due diligence on your vendors to ensure they are not part of the shell company networks described in recent indictments. You must treat vendor compliance as a technical requirement, just like latency or throughput. Now consider this second strategy, which is more architectural in nature. You need to build hardware abstraction layers into your systems. In software engineering, we talk about decoupling the interface from the implementation. In hardware infrastructure, this means designing your system so that it does not hard-code dependencies on a specific chip manufacturer. If your machine learning framework can run on different types of accelerators with minimal code changes, you have created a buffer against supply shocks. For example, if one vendor restricts access to a specific model of graphics processing unit, your system should be able to switch to an alternative accelerator without requiring a complete rewrite of your training scripts. This requires a shift in how you think about model portability. You should be designing your models to be hardware agnostic as much as possible. This involves using containerization technologies to package your software environment alongside your code. When you containerize your machine learning workloads, you separate the logic of your algorithms from the underlying physical hardware. This allows you to move your workloads between different cloud providers or on-premise servers more easily. If one provider faces restrictions, you can migrate your workloads to another provider that has the inventory you need, provided your abstraction layer supports the target hardware. There is also a third layer of mitigation that involves redundancy in design. Just as you would have backup generators for a data center, you should have backup compute capacity in your architecture. This does not mean buying twice as many chips, which would be inefficient. It means having access to a secondary cloud provider or a different region that maintains the necessary compliance certifications. You might also consider leasing compute capacity rather than owning it outright. This shifts the burden of hardware obsolescence and regulatory compliance to the provider, allowing you to focus on your models. However, you must remain vigilant about the legal implications of these strategies. The case involving Supermicrocomputer underscores the intensifying United States enforcement against unauthorized technology transfers. It is not enough to simply buy chips. You must ensure that the path from the manufacturer to your facility is clear of any prohibited intermediaries. This means maintaining a clear audit trail of your procurement. Every transaction must be documented to prove that the hardware was intended for legitimate use in your specific jurisdiction. If you cannot prove this, your entire operation could be flagged, leading to the seizure of assets or the suspension of your operations. Think of this like building a house in a flood zone. You cannot control the weather, but you can build the foundation higher. You can install flood barriers. You can ensure you have a generator that works when the power goes out. In the context of machine learning infrastructure, your foundation is your compliance framework. Your flood barriers are your hardware abstraction layers. Your generator is your redundant compute capacity. If you neglect any of these, you risk losing everything when the regulatory storm hits. The market impact of these arrests has already been felt. Shares dropped significantly following the news, signaling to investors that the sector is under scrutiny. For you, this means that the cost of compute might become volatile. Prices could spike if demand outstrips supply due to export bans, or certain types of hardware could become unavailable entirely. By preparing your architecture now, you protect your research and your products from becoming obsolete overnight. In practical terms, you should start auditing your current stack. Ask yourself which components rely on specific hardware vendors. Identify the points where your software is tightly coupled to a specific graphics processing unit. Develop a plan to decouple those dependencies. Look into whether your current cloud contracts allow for rapid migration if a provider faces restrictions. These are not just technical questions. They are strategic questions that determine the longevity of your projects. The case of the supermicrocomputer co-founder serves as a cautionary tale about the consequences of bypassing national security export regulations. It highlights the severe personal and corporate risks associated with violating these rules. But for the engineers building the next generation of artificial intelligence, it also highlights the need for resilience. You cannot control the laws of the land, but you can control the design of your systems. By prioritizing flexibility, compliance, and redundancy, you ensure that your machine learning operations continue to function regardless of the geopolitical climate. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.